Question 4 on practice paper 3. Relative to a fixed origin O, the point A has position vector 4i plus 8j minus k, and the point B has position vector 7i plus 14j plus 5k. Find a vector AB. Well, if there's the point A, there's the point B. To get from there to there, vector-wise, we must go from A to O, so minus OA plus OB, as we well know, and that's going to give us 3i plus 3j plus 6j plus 6k when we work it out. Now we can simplify this a little bit and say that's the same as 3 into I plus 2j plus 2k. And that's the direction vector down the line AB. If we multiplied it by a negative number, we'd be going that way, and the positive number that way, but in that direction. So we can say a position vector on that line would be, let's go from O to A, and then take a multiple of this. So that's 4i plus 8j minus k, plus some number, let's say mu times I plus 2j plus 2k. Now the next question says calculate the cosine of angle OAB, and I'm going to more or less assume we know how to do this. It's going to be OA dot AB equals mod of OA times the mod of AB times the cosine of the angle in between them, angle OAB. And if you work this out carefully and correctly, you should find that cos of angle OAB, is 2/3. It's the next question that's likely to cause a problem, because it says, show that for all values of lambda, the point P with position vector lambda I plus 2 lambda j plus 2 lambda minus 9k lies on the line through A and B. Well, then, in other words, this is another form of that. Well, let's just check it out. We're saying this R, this position vector, is equal to lambda I plus 2 lambda j plus 2 lambda k minus 9k. Now those are the vectors, so we could rewrite this as minus 9k plus lambda times our friend I plus 2j plus 2k, which we've already come across. So we should recognize that. This must be the same as minus 9k plus lambda I plus 2j minus 2k. However, can we be sure that this point lies on the line AB? Does it lie on that line? Well, if it does, then minus 9k would equal our first one, which is 4 plus mu I plus 8 plus 2 mu j plus minus 1 plus 2 mu k. And if we inspect this carefully, we can see that when mu is equal to minus 4, then R would be equal to minus 9k. So we can conclude from this that R equals lambda I plus 2 lambda j plus 2 lambda minus 9k lies on the line AB. I shouldn't put that there, it lies on AB, the line. Now, for the next bit, we have to say find the value of lambda for which OP is perpendicular to AB, and for that one, you've only got to say OP dot AB equals 0, and work out the value of lambda if you're going to be dotting, let's say, lambda, 2 lambda, 2 lambda minus 9. If you're going to be dotting that with AB, which is 3, 3, 3, 6, 6, and that's got to come to 0, and then you can find the correct value of lambda which does that. So that implies that 3 lambda plus 12 lambda plus 12 lambda minus 54 equals 0. So lambda is equal to 2. So we found that the vector OP is going to be equal to 2I plus 4j minus 5k, and the coordinates of P would therefore be 2, 4, minus 5.